So today we are going to learn how to import data into Amos software. So to import data into Amos software, the first thing that you have to do is to launch your Amos software from your computer. Once you launch your Amos software, you can see that this white space you see here, this is the work interface. This is where you're going to work from. Then you may need to expand this working space. So to expand it, you come here to view, you come to interface properties, then this window will pop up. When this window pops up, you come here to paper size. There are different paper sizes. There are portrait, and there is also landscape paper sizes. To expand this space, maybe you may need to expand to landscape before, then you click apply. So you can see that it has expanded. Then to expand it further, we can use landscape Lego. Then you click apply. Then you can see that space has expanded to the maximum. Now you have a bigger space where now you can build your models the way you want. So now after that, then we go to import our data. So you select this icon here, select data files, you click on it. Then a window will pop up. This window, to import the data from your computer, click on file name. Then it will take you to your computer. So you search where your data is stored. So my data is stored in this file here. So this is the data. My data is stored or is saved in form of an SPSS file. So you click on that data and you click open. But before we import that data, I want to show you that you can import various forms of data into Amos. Amos is compatible with different forms of data. So the first one is that you can import Excel. You can see these Excel files, Excel 3, 4, 5, and 8. You can also import .dbf files. You can also import .sav. This is IBM SPSS statistics files. You can also import CSV files. Yeah. So depending on your on the type of the data, how you have saved your data, then you click on it, then you click open. Once you click open, then your data will be fed into this window here. So this file, it shows the file name. So my file is data, it's called data. It is data.sav because my data is saved in form of an SPSS file. Then here it shows n. You see this n. This is the number of or the sample size. N represents the sample size. So my sample size is 374 respondents or 374 observations. Then to import the data, you click OK. But if you click this icon here, view data, then you will be able to see your data. Your data will be will pop up in form of from the software you have saved it. If you have saved it in SPSS, then it will be shown in SPSS. If you have saved it in CSV or in Excel, then it will be shown in form of CSV or Excel. So to import the data into Amos, you click OK. So now the data has been imported into Amos software. So you come here to see the list of variables in your dataset. So you click this icon, then this window will pop up. It shows the number of variables in your dataset. For instance, in my dataset, I have all these variables. In my dataset. So that is how you import the dataset into your Amos software. So the next video that we shall cover is that we are going to learn how we are going to learn the difference between latent variables and observed variables in Amos software. So make sure you check the next video so that you can also learn the differences between latent variables and observed variables, and also how to draw them in Amos software. Also make sure to subscribe and like this video if you have learned something important. Thank you. So today we shall be learning the difference between latent and observed variables in structural equation modeling. Okay, we shall be differentiating between the latent and observed variables in SEM. So let us look at the differences first. So the first thing that we should note about the difference is that the latent variables are inferred or they are developed from the the latent variables are inferred or they are developed from the observed variables. That means that from the observed variables, then we develop the latent variables, while the observed variables are directly measured. The observed variables are directly measured. That is a major difference between the two. We know that the latent variables are developed or they are inferred from the observed variables, or the observed variables themselves, they can be measured, they can be observed. That's why they are called actually observed variables, because you can be able to observe them. So if we continue, let us look at the latent variables. We are seeing that these are unobserved variables that represents the variance shared among the tasks. They cannot be observed. That's why they are developed from the observed variables. But when you come to the observed variables, these are directly measured. They can actually be observed. They can be counted. For instance, if you're answering a questionnaire, that particular question is an observed variable. So if we have a questionnaire with 5 questions, these questions are actually observed variables. Then when you combine them together, then you can develop latent variables from them. So let us look at an example. For instance, in a questionnaire, we have latent variables here, then we have observed variables on the other side. So if we can have a latent variables which measures health performance, but you cannot be able to measure health performance. So to measure these latent variables, we use the observed variables. So we have 4 observed variables. The first observed variable is life expectancy. Life expectancy can be measured, it can be observed. By what? By the average life expectant at birth. Maybe the average life expectant is 50 years, 60 years. So that one can be observed. Another observed variable that is measuring health performance is infant mortality, the number of infant deaths per 1,000 live births. You see, so that one can be measured, so it becomes an observed variable. Another one that can also another observed variables is the health access. Another one is physical activity level, percentage of individual meeting recommended physical activity guidelines. So you see now, for observed variables, you can be able to measure them. When you combine them together, the life expectancy, infant mortality rate, healthcare access, and physical activity level, when you combine these observed variables, then you can be able to tell the health performance. Now the health performance is a latent variable. Another example is an education performance. Education performance is a latent variable. This latent variable is measured by 4 observed variables. The first one is literacy rate. You can be able to measure literacy rate based on the percentage of people aged 15 and above who can read and write. Maybe the percentage is 20%, 40%. So you can be able to tell the percentage of the literacy rate. So that one is an observed variable. And that one is school enrollment rate. You can be able to tell the standardized test scores, the graduation rate. So this one you can be able to measure them. When you measure this one, they becomes observed variables because they can be measured. When you combine the 4 of them, now you can be able to tell the education performance, which is now our latent variable. So let us look how we represent an illustration between an illustration to tell the difference between the latent and observed variables. So when you are constructing a SEM model, structural equation model, so this one here, this one VR is a latent variable. Let's see, in this case it can be education performance, it can be health performance. So this is our latent variable there. Then this latent variable is measured by 5 observed variables. 5 observed variables. In our case, in our example here, our health performance latent variables being measured by four observed variables: life expectancy, infant mortality rate, health access, physical activity level. So in this illustration here, this latent variable is measured by 5 observed variables: VR1, VR2, VR3, VR4, VR4, and then VR5. And then when you are developing this model, we always put errors, so they can be error. These are errors. You can see each observed variables has its own error. So that is actually the difference between the latent variables and observed variables when you are constructing SEM. So make sure you watch the next video, which I will illustrate how do you draw them in Amos. How do you draw the latent variables and observed variables, and also the errors in structural equation modeling when you are using Amos software. So make sure to check that video. Thank you. So in the previous video, we were learning about the differences. We looked at the differences between latent and observed variables, and I took you through the differences between the latent and the observed variables, and also showed you an example of the latent variables and observed variables, and also give you an illustration. So as I promised, in this video we are going to see how we draw latent and observed variables in a SEM model. We start by with a new workspace. When you open a new workspace, we can expand the interface. So we can use a landscape. Then we click apply. So this is the workspace that we have. So to draw the latent observed variables, we use this icon here. You can see it is written: draw a latent variable and add an indicator to the latent variable. So an indicator means the observed variable. So you just click on it once, then you click here. Let's assume that this is our latent variable now. Let's assume our latent variables has 5 observed variables. So you click on it again: 1, 2, 3, 4, 5. So you can see we have added 5 observed variables on this latent variable. So you click on it again so that you can deselect. So now you can change the alignment of this diagram. So you click on this, rotate the indicators. You can rotate it like that. So you can rotate it like that. So you can see that this one is a latent variable. This one is a latent variable. It has 1, 2, 3, 4, 5 observed variables. So to move the object, you click on this red icon there, so that now you can be able to move that one. Then you can click on it. Let's assume in our case, in our previous example, we had a latent variable. Let's assume our latent variable is health performance. So you can call this one is health performance. So you can write health performance in short form. You can also write here health performance. Then you can see the HP health performance in issues has been added there. Then you can also change this one to change the appearance of these observed variables and the errors. You click this icon here. This one, it preserves the symmetries. When you click on that, you select it, then you click on that, so that now you can be able to change, to move them all of them. You can be able to move. You can see that I have moved all the errors together. And then let's now import the data. So you come here to import the data. You click file name. It takes you to the your data is stored in the laptop. So that's data. This is my data. You just click on that data and you import. You can see that the data has been fed into this window. Then you click OK. So now you have imported the data. Now you can see the variables. You click there to see the variables. So these are the variables that I have. So let's assume this HP, it has how many observed variables? Let's see, it is this observed variable. So you click on that, you carry it, you click on it, and you have to click and hold the button on your mouse, then you carry it like that. You click on it, you select, you carry it, you click, you hold your mouse, you carry it up to where the observed variables is. Then you can close that one. So but you can see that these observed variables are not being seen. So you come here to plugins and then you say resize observed variables. When you click that way, you can see now they have been resized, and then you can be able to see all the full names of the observed variables. But you can see in this case the errors has not been put. You come here again to plugins and then you say name unobserved variables. You click on that, so you can see now the errors has been saved: error 1, error 2, error 3, error 4, error 5. But again you can see that they are not being seen clearly. So to adjust the appearance of these errors, you click here to select this one. Then you come here, this one is 4, this one is 4. Change the shape of the objects. You click on it to select it. Then you can be able to change all of them like that. So that is how you draw. That is how you draw the latent variables and observed variables and their errors in Amos. So let's add another one just to make sure that you understand the process. So you come here, you can add another one there. Let's assume this one has 4 observed variables. You can put 1, 2, 3, 4. That's 4 observed variables. Then you can rotate like that. Then you can push it. So you can push this one there. You can push it like that. And then you come here, you deselect that one. So then you can feed the observed variables. So let's assume it is WT1, WT2, WT3, WT4 like that. So then we can label this one as SWT, the name of the latent variable. So you can see this latent variables is being measured by 4 observed variables named WT1, WT2, WT3, WT4. So then again for this one, you resize the observed variables. You come here, you say resize the observed variables. You can see they have been resized. Now you can be able to see WT1, WT2, WT3, WT4. Then we insert the errors. So you come here to plugins, then you say name the unobserved variable. You click, so you can see the errors has been put. So our errors here was error 1 up to error 5. Then here we start to error 6 up to error 9. So you can also change the size of these errors so that you can be able to see like that. So you can see this error 1 to error 5, this error 6 to error 9. Then you can be able to carry the whole model like that. Maybe put it there. Then you can draw the direction. Connect it like that using this arrow, this one arrow here. You connect them between HP and WT. This one means the effect of HP on WP. How does HP affect WT? So because this arrow is moving from HP to WT. So generally that is how you draw the observed variables and latent variables in Amos. Thank you. So today we are going to learn how to develop or how to build a structural equation model in Amos. So you can see in this picture, in this model, we have already developed a good model, a good and beautiful model of structural equation model. So in this case, we have the independent variables AI, WT, and PT, and then we are seeing how they affect TS. How they affect TS. TS is technical skills. AI is AI training. WT is weekly training plan, and PT is physical training. So we are looking at how does these three affect the technical skills. So I want to take you step by step on how to develop such a good model. So we first look at the data. So if we open the data here, we can see this is our data in SPSS. So we have the four variables. The first one, the second one, AI. The third one is physical training, and the fourth one is technical skills. So you can see for weekly training plan, we have 5 observed variables. For AI training, we have 5 observed variables. For physical training, we have 5 observed variables. For technical skills, we have also 5 observed variables. So each of these variables are measuring their latent variable. So this one are measuring one latent variable. This one are measuring another latent variable, another latent variable. So that now we can have these four latent variables. So we can also check at the data. We can see that this one is a Likert scale data. It's a 5-point Likert scale data, and then you can see the number of variables that we have. The number of values that we have is 374. Is 374 responses. So now we come here to the model. We have seen that we want to develop a model like this. So I want to take you step by step of how to develop such a model. So the first step is come here, you click new. Now you create a new interface. So you can see this working space is quite small, so you may need to enlarge it. You go to view, you go to interface, then you can enlarge it by applying the landscape legal. Then the interface becomes quite big. So now the next thing is maybe we can open the original model so that we can compare side by side. And we have seen that we have 4 observed variables. We have 4 latent variables, 2, 3, 4. And we also said, so we can see in this model we have 1, 2, 3, 4. So and we can see that each has 5 observed variables. So you can come here and add 5 observed variables in each of these latent variables. So these are 5. These are 5. That are 5. These are 5. And then another thing we can do is that now we can label them. This is AI, WT, PT, and TS. So you can come here and label them so we can see that. So to label them, this one is it, that this one is AI. You label it here like that. So the second one is WT. So this one is WT. Then the third one is PT. So this one is PT. The one is PT. And the last one is TS. So this one is TS. That one is TS. That one is TS. So the other thing that we can do is to rearrange them according to the way these ones are arranged. We can rotate. We rotate the observed values. So to rotate, you click on that one. So you can rotate that one, rotate that one, and rotate that one, then also rotate this. The other thing is that we need to move the WT so that its observed variables are not overlapping with that of AI. So click there and there, then you carry it like that. So you can see now you have at least a good space to work in. You can even drag them behind a bit. So the next thing is to import the data. You click here, import the data, you click file name. So when you click file name, you begin to where your data is stored. So you click on that data, you click open. So you can see now the data has been imported to that interface. You click OK. Then now you can see your variables there. So these are our variables. So the first one is AI. So the first one is AI. So you can see this is our AI here. So you can carry that one there. The second one, the third one, the fourth one, and the fifth one. Then you come to WT, carry the first one, the second one, the third one, the fourth one, and the fifth one. Then you come to PT. So PT1, PT2, PT3, PT4, and PT5. Then you go to TS. Go to TS. So TS. Sorry, this one is PT4. This one should be PT5 like that. PT1, PT2, PT1, this PT1, PT2, PT3 should be this one. PT4 should be this one. Okay. Then we go to TS. When you come to TS, so it is TS1, TS2, TS3, TS4, TS5. So now, but you can see in this model, most of the data is overlapping. You can see the names of the observed variables are overlapping with the error terms. So what we should do is that we should move the error terms a bit to the left, and also for the TS we move them to the right. So you come here and select that one and that one. You can be able to move the error terms of that like that. You can move the error terms a bit. You can move the error terms a bit like that, and also you can move these error terms a bit to the right. The other thing, you can also see that the names of the observed variables are not fitting to the space given. So what you do is that you come here to plugins and you click resize observed variables, and you can see that they have been resized. They have been resized to the next, but they are overlapping with the name with the latent variables. So you can deselect that one and click on that. Then you can carry the latent variables like that. You can carry that one. You can carry that one. You can adjust that one like that. Then you can also select this one so that you can now be able to preserve the symmetry. Then you can carry, you can adjust the error terms. You adjust it, adjust them like that. You can see it is appearing better. Then you can also adjust this like that. So the next thing that you need to do is that you need to input all the error terms here. So you come here, you click name unobserved variables, and you can see all the error terms has been put from error term 1, this one, up to error term 20. But you can see that these error terms are not clearly seen. So what you do is that you need to resize them. So having selected that, you click on this whereby you want to change the shape of the objects. You adjust them like that. You adjust them like that. You adjust them like that. Adjust them like that. Then you may need to move the whole of this model, the whole of these latent and observed variables to the right a bit. Then remember, our model should look like this. Our model should look like this. So what we do is that we need to connect them. We connect that one to that one, connect that one, and you connect that one. The other thing that we should do is that we may need to make them beautiful. Click on this one, touch up the variable. You touch them up like that. Let's see what else we should do. We also needed to put the error term on these dependent variables. So what we do is that because this TS is our dependent variable, we also need to put an error term. So you come here, you select this one, add a unique variable to an existing variable. You click on it, then you click on that. But this error term is not labeled, so you come here, you click name an observed variable, and it is automatically labeled. So now you can see that we have drawn a very good and nice looking structural equation model in Amos. So these are the steps that you follow to construct a structural equation model in Amos. So in the next video, I'm going to show you how to run this analysis. So I'm going to show you how do you run the analysis of the structural equation model, and also how do you interpret the results. Thank you. So in my previous video, I showed you how to draw this structural equation model. We went through the process of drawing this structural equation model, whereby we have 3 independent variables and 1 dependent variables. So in this video, I'm going to take you through the whole process of running the analysis, how to run this analysis, how to run this structural equation model analysis. So the first thing that we need to understand is that we needed to understand these variables. We have 4 variables here, 4 latent variables, each of which are measured by the observed variable. Remember in my previous video, I explained to you the differences between the latent and the observed variables. So in this video, I'm going to show you how to run this model. So the first thing that we should know is the variables that we have. We need to know the variables. So we have the independent variables, and then we have the dependent variables. So we have 3 independent variables: the AI training, which is this one. Then we have weekly training plan, which is this one, WT. And then we have the physical training, which is this one. So these are the independent variables. Then we have the dependent, which is technical skills acquisition, which is our TS here, the technical skills acquisition. So we are measuring how does these 3 affect technical skills acquisition. In other words, how does AI training, how does weekly training plan, and how does physical training affect technical skills acquisition. So having understand the variables, then we can look at the objectives. So we set objectives for each of these relationships: the relationship between AI and TS, WT and TS, and PT and TS. So we develop a relationship, we develop objectives for each of these relationships. So for the first objective is to determine the effect of AI training, this one, on technical skills acquisition, and to find out the effect of weekly training plan on technical skills acquisition, and then to investigate the effect of physical training on technical skills acquisition. So in other words, we are trying to find out how does each of these independent variables affect the dependent variables. Then from that means how this relationship, how does AI affect relationship, affect TS, how does WT affect TS, how does PT affect TS. That is why we have this arrow. It is moving from AI to TS. The effect of AI on TS. The arrow is moving from WT to TS. The effect of WT to TS. And this arrow is moving from PT to TS. Remember, the direction of the arrow shows the direction of the effect. Okay. Then from each of these objectives, we develop the hypothesis. One thing you should note is that hypotheses are developed from the review of the literature. Having developed the objectives, then you go and review the literature, and from what you find in the literature, you develop the hypothesis. So in our hypothesis, we say that AI training has a positive and a significant influence on technical skills acquisition. Weekly training plan has a positive and significant influence on technical skills acquisition, and physical training has a positive and significant influence on technical skills acquisition. It means each of these independent variables has a positive and significant effect on TS. That is what we hypothesize. That is what the literature review tells us, meaning that each of these positively affects physical training, physical training skills acquisition. Okay, so having set the hypothesis, the next thing is to run the analysis. So now we come here, you can see that this icon here is not active, so we cannot be able to see the results. So we need to run this model so that now we can be able to see the results. So the first thing is to import the data. In my previous video in this series, I showed you how to import the data into Amos. So you click on this file, takes you to your computer, you click on the data that you want to use, then you import it to this window, then you click OK. Having imported the data, then you click on this window which says analysis properties. When you click, a new window pops up. So now I had already selected the output I want. So this window, if you click on this estimation, there are different estimations you can carry out. You can carry out maximum likelihood, generalized least square, and weighted least square, scale free least square, or asymmetric distribution free. But we stick with the maximum likelihood estimation. Then you go to output. So these are all the outputs that Amos can produce, all these. But for this model, we stick with the maximum minimization history, and also we stick with standardized estimates. We also stick with squared multiple correlations. Then we select the indirect, direct, and total effects. We need to see the direct, indirect, direct, and total effects. Then we go to total scores, factor score weights. Then we go to the covariance of estimates, and we also check the correlations of estimates. So these are the results we need for now. Maybe in a later video I will show you what it means on the other output. So having selected what we need, the output we need, then we close that window, and then we click on this icon here. So this one, it says calculate estimates. So we click on it, and then the model will start to run. So you can ignore this message which says Amos will require the following pairs of variables to be uncorrelated. So you just ignore that one and click proceed with the analysis, and then Amos will start run. You can see at the end, at the right corner, the analysis is running. Once the analysis is completed, then this icon here, you can see it has changed to green. Then you can click. When you click on this, you can see the results has appeared. You can see if you click on the left one, the results disappear. When you click on the right one, now you can be able to see the results. Yeah. So we have two types of results. We have the unstandardized estimates, and we have the standardized estimates. So if you click standardized estimates, you can note that there is slight changes in the factor weights. So these values you see here in this arrow, in this line, these are the factor weights. So these factor weights can be, or what we call the factor estimates, they can be either unstandardized. So you can see they are changing. These are the unstandardized one, or they can be standardized. They can be unstandardized or they can be standardized. So now to see the results, we click on this icon here. It says view text. When you click on it, the output now will appear. The output will appear. So that is the output for that model. So there are different output that we may need to check. The first thing is the notes for the model. If you see, click here, notes for the model, you get these results. It gives you the chi-square result, it gives you the degrees of freedom, and it also gives you the probability level. And another thing that we may need to, you can click here on the estimate to expand it. Click there, then you click on scales, you expand. Then you click on regression weights. So this is the regression weights. What we are particularly interested in is this regression weights here. This regression weights. So this regression weights is the first three: the movement from AI to TS, WT to TS, PT to TS. These three. Let me highlight for you here. That one. These are the major ones that we are interested in. So what you should remember is that to get the results, we check the regression weights. You click on the regression weights, then you get the results here. Then you can see the effects of the independent variables on the dependent variable. You can also check the standardized regression weights here, these ones. But what we are interested in is the regression weights, which gives the standard errors, it gives the CI, it gives also the p values. So I have copied the three and put them on a Word file. Here it is. You can see this one is 0.373. If you come here, you can see that this one is 0.373. This one is 0.128. So this one is also 0.128. So I want to explain how we interpret these results. So you can see this one was our hypothesis 1. This one, AI has positive and significant effect on technical skills acquisition. So hypothesis 1, effect of AI on TS, effect of WT on TS, effect of weekly training plan on the technical skills acquisition, and the third hypothesis was the effect of PT, physical training, on TS, technical skills acquisition. So these are the regression weights, or what we call the beta weights. So you can see in this beta weight here for the first hypothesis, it is 0.373, and it is positive because it is not negative, it is positive. So if the standard error is 0.058, but if we check the p-value, the p-value is it has 3 stars. This 3 stars means it is significant at 0.01 significance level, at 99% confidence level. Then so I have explained it here. You can see that AI training has a positive because this one is positive, and significant because the p-value is less than 0.01. Influence on technical skills acquisition, because you can see here our beta is 0.373, and our p-value is less than 0.05, at 95% confidence level. So then we go to hypothesis 2, this one. So this is our hypothesis 2. This is where I have written the results. So we are saying weekly training plan has a positive because this value here is positive. You can see this value here is positive 0.128, and significant because this p-value here is less than 0.05. So we can say weekly training has a positive and significant influence on technical skills acquisition. Then you put into bracket that beta is equals to 1.28, and p-value is less than 0.05. Then you go to the last one. The last one is physical training. Sorry, this one should be physical training. So physical training has a positive and significant influence on technical skills. So it has a positive, this 0.814 is positive, and it is also significant because the p-value is less than 0.05. So physical training has a positive and significant influence on technical skills acquisition. So you put into bracket that the beta is positive, so 0.184, and p-value is less than 0.05. So now that's how we run and interpret the results for the structural equation model. So today we are going to learn how to interpret the structural equation model results. So we had already, in our previous video, we had already learned how to conduct a structural equation model analysis. So we have the structural equation model analysis results in this model here, you can see. So as we said in the previous video, we have two types of results. We have the unstandardized results and the standardized results. So you can toggle between the two. So you can see if you click on the unstandardized results, you can see there are some changes, and if you click on the standardized results, you can also see there is some changes. So we are going to see how do we explain these results, how do we interpret these results. So you can see that we have three independent variables. The first one is AI, the second one is WT, and the third one is PT. We are trying to look the effect on the TS. So these three variables AI, WT, and PT, and the dependent variable TS are explained here. AI is AI training, WT is weekly training plan, PT is physical training. So we are trying to see how does these training variables affect technical skills acquisition, which is our TS. So we are trying to see how does AI training, weekly training plan, and physical training affect the technical skills acquisition. These are the variables in the study. So this is our model, which has already been conducted. The results has been already obtained. So you want to see how do we interpret these results. So if we first look at this model, we can see that the effect of AI on TS, the regression weight here is 0.37. 0.37. That means it's quite. It is below the mean. It is below 0.5, which means that it is quite low. If you look at the effect of WT on TS, you can see it is quite minimum. It is 0.13. It is quite retro. If you look at the effect of PT on TS, it is 0.81. This one is very strong. It has very strong effect on TS. So comparing the three, we can see that PT, physical training, has the highest effect. Physical training has the highest effect on technical skills. Then it is followed by AI training, and then the last one, which has the least effect, is the weekly training plan. So that is according to the model that we can see. So we can also now look at the results. We click on this tab here to check the results. So these are the results. So you can see if you click on the estimates, you see the results. So we have what we are interested in is these three lines, these three rows, row 1, row 2, and row 3. So the effect of AI on TS, the effect of WT on TS, the effect of PT on TS. So these are the regression weights, the results of the regression weights. So you can see if you click on this one, 0.37, if you click on that, you will get that you get the results being explained that when AI goes up by 1 unit, TS also goes up by 0.3 units. It means that if AI increases by 1 unit, TS increases by 0.37 units. Similar results are explained on the second one. So if you click on that, you will see that when WT goes up by 1 unit, TS goes up by 0.128 units. If you click on the third one, you can see that when PT goes up by 1 unit, TS also goes up by 0.811 units. Then you can also look at the standard errors. You can click on that and then you see that the results for the standard errors are explained. That when the regression weight estimate 0.373 has a standard error of about 0.58. So you can see that these are the standard errors of this regression weights. This is the standard error of this regression weights. This is the standard error of this regression weight. Then you can also check the standardized z values. So these are obtained by dividing. So dividing the regression weight estimate by the estimate of its standard errors, it gives the z value, the z. So you can see if you take 0.373, if you take this one, then you divide by the its standard error, then you get the z value or the standard errors value. So in other words, the regression weight estimate is 6.45. This one here, the regression weight estimate is 6.45 standard errors above 0. And the third one that we should check is the p-value. The p-value, this one tells us the significance. So the probability of getting critical ratios as large as 6.45 in absolute value is less than 0.001. In other words, the regression weight for AAI, this one, the regression weight for AI in the prediction of TS is significant. So the keyword here is this one. It is significant. It is significantly different from 0 at 0.01. In other words, what we are saying here is that the effect of AI on TS is significant because it is less than 0.001. The same case in this one. It is also significant. It is significantly different from 0. Then the same case is obtained in the third relationship, whereby the effect of PT on TS is also significant. So this stars shows a very high level of significance. It is less than 0.0001. It is almost the p-value here is almost 0. So it is very highly significant. So that is how you explain the results. We may also need to check the standardized regression weights. So you come here to estimates, you open it, you go to standardized regression weights, you click on it. So these are the standardized regression weights. We are particularly interested in the effect of AI on TS, the effect of WT on TS, the effect of PT on TS. So if you click here, then you can be able to explain this standardized regression weights. So it says when AI goes up by 1 standard deviation, TS goes up by 0.39 standard deviation. So the main difference here between the standardized regression weights and the regression weights themselves is that for the standardized regression weights, we talk about standardized deviation or standard deviations. But when we come to the regression weights themselves, you can see here, we are saying when AI goes up by 1 unit, then TS goes up by 0.373 units. But when we come to the standardized regression weights, we say that when AI goes up by 1 standard deviation, then TS goes up by 0.39 standard deviations. So it will depend on what you use to explain the results. But basically, we usually use the regression weights because the regression weights gives us the standard errors, they also gives us the z values, and they also give us the p values. So generally that is how we explain the results. That's how we interpret the results of a structural equation or model.